Hello everyone, this is Bijective. Welcome to my YouTube channel. I hope you are all safe at home. And the basic requirement to study the types of function, right? What is function? If I consider a function, if I consider the relation f from a to b, every element of a has a unique element in set b. If I consider a relation f from non-empty set A to non-empty set B, this is said to be a function when every element of A has a unique element in set B. Then I also discussed about the types of function, right? There are two types of function, namely 1, 1 and onto. 1, 1 and onto. What is 1, 1? If I consider a function f from A to B, for every a1 comma a2 belongs to the domain A, consider f of x1 is equal to or f of a1 is equal to f of a2. That should implies a1 is equal to a2. This is the procedure to prove the given function is 1, 1. We need to find f of a1 and f of a2. Then we need to get a1 is equal to a2. Then we say the given function is 1, 1. Then what is for onto? If I consider a function f from a to b, for every a belongs to the set A, there exists an element b belongs to the set B such that f of A is equal to b. That is range of the function f should be equal to codomain of the given function f. I already discussed about the range of the function. What is the range of function? Set of all second elements in an ordered pair is called range of function. And what is codomain? If I consider the function f from A to B, this whole set is nothing but a codomain. So to prove the given function is onto, we need to check whether the range of function should be equal or not equal. A function f from A to B is said to be onto if and only, this is what? If and only if condition range of f is equal to codomain of f. If range of f is equal to codomain of f, then we say the given function is onto. The given function f from A to B is said to be onto if range of f is equal to codomain of the given function f. This is if and only if condition. Yes, in this session I am going to solve some problems on types of function. Let us consider the problem. See, check, examiner like to ask this type of question in your part B. Okay, check injectivity and surjectivity of the following function. See, the first function f from natural number to natural number defined by f of x is equal to x square. Then the function f from real number to real number f of x is equal to x square. Then the function f from set of integers to set of integers such that f of x is equal to x square. Then the function f from natural number to natural number such that f of x is equal to x cube. Then the function f from real number r to real number r such that or set of integers to set of integers such that f of x is equal to x cube. See, examiner like to ask these type of questions for your annual examination in part B. Okay, check injectivity and surjectivity. Injectivity is nothing but 1, 1 and surjectivity is nothing but onto of the following function. See, let us consider the first one. Given function given function f from n to n f of x is equal to x square. Okay, then for one see, for every a1 comma a2 belongs to the domain a, f of a1 is equal to f of a2. We should consider f of a1 is equal to f of a2. Here they given f of x is equal to x square. So let x1 comma x2 belongs to set of natural number n such that consider f of x1 is equal to f of x2. See, if f of x is equal to x square, what is f of x1? This is equal to x1 square. Then what is f of x2? This is equal to x2 square. See, this implies x1 is equal to plus or minus square root of x2 square. Square root square get cancelled. Then we are remaining with plus or minus x2. See, for all x1 comma x2 belongs to the set of natural number, we have only positive values, right? Because x1 comma x2 belongs to set of natural number. x1 should not be equal to minus x2 because x1 x2 belongs to what? Natural number. Natural number starts from 1 2 3. It contains set of all positive integer. Okay, therefore x1 is equal to x2. This implies, according to the definition, f of a1 is equal to f of f2 implies that a1 is equal to a2. Then we say the given function is 1 1. Here f of x1 is equal to f of x2 implies that x1 is equal to x2. This implies what? F is 1 1. F is 1 1. Then for onto, what about onto? We need to check whether range of function is equal to codomain of f. What is codomain here? Codomain of the given function f is equal to what? Set of natural number. I already told you this whole set. If you consider f from a to b, then whole set b is the codomain. Here, what is the codomain? Set of all natural number. This is equal to what? 1 2 3 etc. Fine. Then let us check about the range. What is range of f? According to the given function, f of x is equal to x square. See, range means output. Set of all second elements in an ordered pair for the given relation. Here, output. Whatever we are given an input, then we take output. That output is nothing but a range. See, if I put x is equal to 1, this is equal to what? 1 square. If I put x is equal to 2, then 2 square, 3 square, etc. Then 1 square, 1, 2 square, 4, 3 square, 9, etc. See, set of natural number is the codomain, but here we are missing 2, 3, then 5, 6, 7, 8, then like this, right? So this should not equal to what? Codomain. This should not be equal to codomain of f. That is what? Codomain of f is what? Set of natural number. This is not equal to set of natural number. That is, range is not equal to natural number. Then we conclude, therefore f is not onto. F is not onto. Therefore f is injective. F is injective, but f is not surjective. F is not surjective. Here both domain and codomain are very important. Okay, consider the function f from natural number to natural number. Then for the given function, this is 1 but not onto. Okay, let's move on to the next one. Please note down this. Yes. Okay, then consider the second one. See, this one is over, right? This one is over. Then consider the given function f from here. What is the domain? Set of real numbers. Codomain is also set of real numbers. The function is same. F of x is equal to x square. Yes. Let us check one more. Already told you, let x1 comma x2 belongs to set of real number. See, f of x1 is equal to x2. See, this implies what? x1 square is equal to x2 square. This implies what? x1 is equal to plus or minus x2. Square root of x2 square. Square root get cancelled. Then we are remaining with what? x1 is equal to plus or minus x2. Right? Here we are getting x1 is equal to plus x2 and x1 is equal to minus x2 also. According to the definition, f of a1 is equal to f of a2 implies that a1 should be equal to positive a2 only. Here we are getting the negative values because minus x2 belongs to the real number. Real number contains both negative and positive. Therefore, f is not injective. F is not injective, right? For example, see, f of minus 1 is equal to f of 1 is equal to. See, f of minus 1 is equal to what? Minus 1 whole square. What is minus 1 whole square? 1. What is f of 1? 1 square 1. See, distinct elements of the domain getting the same images. That contradicts the definition of what? 1 1. Therefore, it is not injective. But if you say, sir, what about in natural number? F from n to n. Here also f of minus 1 is equal to 1. But my question is it minus 1 belongs to natural number? No. Right? Minus 1 does not belong to natural number. We should consider the input also natural number only. F from n to n. So, from n to n, the given function is 1 1. But from r to r, the given function is not 1 1. Let us check about r2. What about r2? See, here, codomain is what? Codomain is set of all real number. Is it equal to range? See, let us check. Range of f is equal to, see, 0 plus or minus 1 whole square plus or minus 2 whole square and etc. See, and it contains all the elements from 1 to 2, 0 to 1 like this. But this is not equal to codomain. Codomain, what is codomain? 0, 1, plus or minus 2 whole square is 4, then 9, etc. It contains only positive numbers, especially positive natural numbers only, not all positive, not all natural numbers. It contains 0, 1, 2, 3. Where is minus? No, right? Here range is not equal to codomain. Therefore, the given function f is not onto. In f from r to r, I already told you, right? Here domain and codomain are very important. If I consider the function f from r to r, that is real number to real number, then the given function is not 1 1 and not onto. See, similar example. If I consider f from integers to integers, it also contains what? Both negative and positive numbers. See, x1 is equal to, here also getting in f from z to z, we are getting the same result. x1 is equal to plus or minus x2. Therefore, f is not injective. See, for all x1 from x2 belongs to what? Set of integers. That's all. Here, codomain is equal to what? Set of all integers. If I consider the range of f, see, 0 plus or minus 1 square plus or minus 2 square up to etc. What is codomain? Codomain is equal to 0, 1, 4. This is not equal to set of integers. It does not contain the negative values and it breaks, right? Where is 2, 3, where is 5, 6, 7, 8, right? So this is not equal to set of integers, right? Therefore, f is not onto. In the case of f from natural number to natural number, f is 1 1 and but f is not onto. But in the case of real number to real number, z to z, f is not 1 1, f is not onto. Then I give these two problems to do yourself only. Okay, I leave this problem to you only. So please think about it. What happens if the function is x cube from natural number to natural number and integers to integers. Okay. Yes. Let us move on to the next set of problems. Here they given to show that the function f from r0 to r0, r suffix 0 to r suffix 0. What is r0? Where r0 is the set of all non-zero real number. Why it is non-zero real number? Let's see. Defined by the given function is what? F of x is equal to 1 by x. If I put x is equal to 0, what happens? It is not defined. That's why they given the both domain and codomain as set of all non-zero real numbers. It is 1 1 and onto. Okay. Then what is the solution for this? Answer. Okay. Let x1 comma x2 belongs to set of non-zero real numbers. Consider what? F of x1 is equal to f of x2. Okay, then what is f of x1? 1 by x1. Then what is f of x2? 1 by x2. Because the given function is what? F of x is equal to 1 by x. What is f of x1? 1 by x1. What is f of x2? 1 by x2. This implies yes, x1 is equal to x2. Since both are in denominator, cross multiply this, x2 this, x1 this, therefore x1 is equal to x2. By taking f of x1 is equal to f of x2 for all x1 comma x2 belongs to the given set of non-zero real numbers, that implies x1 is equal to x2. This implies what? If it's 1 1, then you will get 1 mark. Then we need to prove what? Onto, right? Let us consider onto part. Then what is range? Range of f is equal to set of all non-zero real numbers, right? If I consider 1 by x, put x is equal to 1, 1 by 1 divided by 1.1 point something, right? Whatever we given as input, we getting all outputs. That is, what is output here? Set of all non-zero real numbers only. Set of all non-zero real numbers is nothing but what? Codomain of f. Therefore, this implies what? F is on. Very simple. Then you prove f is on. Again, you will get 1 mark. So this is the question for 2 mark. See, these are the problems very important to study the next topic, that is invertible function. What is invertible function? We discuss it later. But to study an invertible function, we need the definition of types of function, and we need how to prove the given function is 1 1 and onto. So these are all very basic problems to study an invertible function. Please go through it. Okay, I hope you are all getting this one. Okay, then I move on to the next. Prove that the greatest integer function in the very first class only, that is last class only, I given some important functions and their graph. Greatest integer function, modulus function, signum function, constant function, identity function, right? Here they given, prove that the greatest integer function f from set of real numbers to set of real numbers given by f of x is equal to what? That is square bracket of x. We denote the greatest integer function as square bracket of x, where this x is greatest integer. What is the definition for greatest integer? Less than or equal to that x. That is less than or equal to x. Yes, let's move on to the problem solution for this problem. Okay, then given function f of x is equal to x. I already told you it is greatest integer less than or equal to x. Okay, see, if I consider the number line 0 to 1, that is closed into 1, 0 to 1. What is the meaning of this? It contains 0 but it does not contain 1. See, if I consider this number line, this is 0. Okay, 0, 0.1, 0.2, 0.2 up to 0.1. This is 1. This is open bracket. This interval does not contain 1. Okay, this is open closed interval, this is open interval. Then my question is, what is f of 0.1? What is f of 0.1? It is integer less than or equal to x. If I consider this point 1 less than or equal to x, it not be equal to 0.1 because it is a greatest integer function. So 0.1 is what? Is greater than 0, but 0 is what? Less than or equal to 0.1. According to the definition, f of 0.1 is equal to 0. This also equal to f of 0.9. If you consider 0.9, then the greatest integer of 0.9 is what? It is also 0. See, for distinct elements of input, you will get the same output. According to the definition, what you will get? You should get, for different inputs, you will get the distinct output, that is, let us consider f of x1 is equal to f of x2 implies that what? x1 is equal to x2. See, f of x1 is equal to f of x2 implies that what? x1 is equal to x2. Here x1 is what? 0.1, x2 is what? 0.9. Is it 0.9 is equal to 0.1? This is my question. Is it x1 is equal to x2? It is not possible, right? Therefore, f of x1 is equal to f of x2 implies that x1 not equal to x2. Therefore, f is not 1. F is not 1. See, is neither 1 nor on 2 means not 1 not on 2. See, let us consider the second part, that is second type on 2. On 2. See, what is range? What is range of set of real numbers? You will get in what? Set of integers, right? According to the definition, whatever we will give an input, we will get the set of integers only. See, 0.10, 0 is an integer, 0.90. If I give 100, 0.1, what is the greatest integer of 100.1? 100. This is the integer, right? So range of the given function f, range of the given function f is equal to set of integers. This is not equal to codomain of f. What is codomain of f? This is not equal to codomain of f. What is codomain of f here? Set of all numbers. Therefore, this implies f is not on. Therefore, f is neither 1 nor on 2. That is, f is neither injective nor surjective. Okay? Next, move on to the problem. Next problem is that A is equal to set contains what? Elements 1, 2, 3 and B contains elements 4, 5, 6, 7 and they define a function f is equal to 1 is related to 4, 2 is related to 5, 3 is related to 6, be a function from A to B. Show that it is 1, right? See, if I consider the mapping f from A to B, here set A contains the element 1, 2, 3 and set B contains the element 4, 5, 6, 7. Here 1 is related to 4, 2 is related to 5, 3 is related to 6. Different elements of A, that is different elements of the domain, contains the distinct elements of B, distinct images in B, right? Therefore, we can write here different elements of domain A contains different images in codomain B. Therefore, f is what? F is 1, 1. My question is it onto? Think about it. According to the definition of onto, for every y belongs to the set B, there exists an element x belongs to the set A such that f of x is equal to y. See, what is the pre-image of 7 here? 7 does not contain any pre-images, right? Therefore, since 7 does not have pre-image, therefore it is not. F is not on. This is additional question. They given to prove f is 1, 1. That's all. This is additional question. Here f is not on. Yes. Next, move on to this problem. In each of the following cases, state whether the function is 1, 1 or onto or bijective. When we say the given function is bijective, the function is both 1, 1 and onto, right? See, here they consider the function f from set of real number to set of real number defined by f of x is equal to what? 3 minus 4x, and this is the second sub question, f of x is equal to 1 plus x square. Let us check this. Consider f of x1 is equal to f of x2. Okay? For all x1 comma x2 belongs to what? Set of real numbers. Okay? What is f of x1? 3 minus 4x1 is equal to 3 minus 4x2 plus 3 get cancelled. Then we are remaining with it as what? Injective. Very simple, right? Let us move on to the next type, that is onto. See, for every, according to the definition, for every y belongs to the real number r. For every y belongs to the real number r, there exists x belongs to the real number r. Here, both a and b are what? Set of real numbers only. Such that f of x is equal to 1. See, this implies, what is f of x? 3 minus 4x. This is equal to 1. This implies, what is x? See, 3 minus y is equal to 4x. This implies x is equal to 3 minus y divided by 4. This belongs to what? The domain. What is the domain? Set of all real numbers. See, let us check. F of, what is x? What is x? Here, we should get what? F of x is equal to y. Then for every y belongs to r, there exists x belongs to r such that f of x is equal to y. What we getting? X is equal to what? 3 minus y divided by 4. According to the given function, f of x is equal to what? 3 minus 4x. See, 3 minus 4 instead of y, instead of x, what we have? Open the bracket. 3 minus y divided by 4. Okay, this implies what? 3 minus 4 3 is 12. Then for minus 4y, this divided by what? 4. Take 4 as LCM. 4 3 is 12. Plus into minus, minus 12, minus into minus, plus 4y, plus 12 get cancelled. 4 get cancelled. What we have? Therefore, f of x is equal to 1. What is x? We already find out, right? X is equal to 3 minus 12 by 4. This is the another type to prove the given function is, another method to prove the given function is onto. Okay? Here f is 1 1 and f is onto. Here for all x belongs to set of real number. For all y belongs to set of real number. Therefore f is, since f is both 1 1 and onto, therefore f is what? Bijective. F is what? Bijective. Yes. Next we move on to this problem. F of x is equal to 1 plus x square from real number to real number. Okay? Then for 1 see here f of 1 is equal to f of minus 1. 1 plus minus 1 whole square is plus 1. Plus 1 whole square is plus 1. 1 plus 1 is what? Plus 2. That is plus 1 is equal to what? 2. Two distinct images getting same range. That is same image. Right? Therefore, according to the definition, f is not 1 1. F is not 1 1. Fine. Then what about onto? What about onto? See, consider f of x is equal to y, or consider the range. Okay, what is range? Range is equal to, see, f of 0, set of real numbers, right? 0. F of 1 plus 1 whole square 2. F of minus 1 again plus 2. F of minus 2 whole square 5. F of plus 2 5. Here you getting set of all positive real, set of all positive numbers. Okay, it does not contain the negative numbers. Therefore, it is not equal to what? Codomain. It is not equal to what? Codomain of f. It is codomain of f here, set of real numbers. Therefore, since range is not equal to codomain, this implies f is not onto. Since f is neither 1 1 nor onto, if one of the type does not count, then it is not bijective. Here f is not 1 1 and f is not onto. That is neither 1 1 nor onto. This implies f is not bijective. F is not bijective. Yes. Let us move on to the next set of problems. Here they given the function f from natural number to natural number be defined by f of x is equal to what? N plus 1 by 2 when n is even. N by 2 if n is odd. For all n belongs to what? Set of natural number. State whether the function is bijective. Justify your answer. Okay? See here the function f from n to n defined by f of n is equal to n plus 1 by 2 when n is odd, n by 2 when n is even. Right? For 1, see what is f of 1? Since 1 is a odd number, we should consider this function, that is n plus 1 by 2. What is n? 1. 1 plus 1 by 2. That is 2 by 2 is equal to what? 1. If I consider f of 2, since 2 is even, we should consider this function. This is equal to n by 2. What is n? 2. 2 by 2 is equal to what? 1. For two different elements of domain, we are getting the same output, that is the same range. It contradicts what? The definition of 1, 1. This implies that this is not 1, 1. This is not 1, 1. Then what about onto? See, what is range? Range of function f is equal to, see, if I put n is equal to 1 plus 1 by 2. 1 plus 1 by 2 is 1. If I put n is equal to 2 by 2, 1, again 1. Then if I put n is equal to 3, odd, 3 plus 1 by 2, 4, this is 2. For n is equal to 4, 4 by 2, 2. Then for 5 and 6, we are getting 3. For 7 and 8, we are getting 4. This is also equal to what? Set of natural number. This is equal to what? See, f from n to n. What is the codomain here? This whole set, the second set. That is equal to what? Codomain of the given function f. Since range is equal to codomain, therefore f is what? F is onto. But f is not 1. Okay? Here we are getting what? For two different elements of domain, we are getting the same images, that is same range. According to the definition, it contradicts. Therefore, it is not 1, 1, but it is onto. Yes, it is very, very important for your examination. Okay? This is also very, very important question for your annual examination. You may expect this question in your examination 2021 April, May. 2021 April, May, then you will face like this. If it is not appear, then you will face like this. Right? So, it is important. Okay? Then, show that the function f from n to n given by f of x is equal to what? X plus 1, x minus 1. If x is what? Odd. And x is what? Even. Okay? Consider the function f from n to n. F of x is equal to x plus 1, x minus 1. If f is odd, if f is even. Okay? Let us consider the three cases. Case 1. When both, let us consider first x1 comma x2 belongs to set of natural number. Let us consider x1 comma x2 belongs to set of natural number. Then the case 1 is when both x1 and x2 are even. When both x1 and x2 are even, then what is f of x1? When it is even, the function is what? X minus 1. What is f of x1? x1 minus 1. Okay? What is f of x2? F of x2, it is x2 minus 1. Since both x1 and x2 are even, this implies, considering what? Considering f of x1 is equal to f of x2, this implies x1 minus 1 is equal to x2 minus 1. Minus 1 minus 1 will cancel. This implies what? x1 is equal to x2. Therefore, f is 1, 1 in this case. What happens in the next case? And what is the next case? You know it. Quick. If both x1 and x2 are even, then the next case is if the both x1 and x2 are odd. What happens? See, for odd function, what is the defined function? For odd, if f is odd, then f of x1 is equal to x1 plus 1, f of x2 is equal to x2 plus 1. Consider f of x1 is equal to f of x2, then x1 plus 1 is this get cancelled. x1 is equal to x2. Yes, x1 is equal to x2. Therefore, in this case also we getting f of x1 is equal to f of x2 implies x1 is equal to x2. Then the third case, when x is odd, when x1 is odd and x2 is even. When x1 is odd, x2 is even. See, is it x1 plus 1 is equal to x2 minus 1? My question is, we should consider f of x1 is equal to f of x2. We should get x1 is equal to x2, right? See, here we are able to write this f of x1 is equal to f of x2. See, if I consider the odd function, x1 is odd, right? For odd function, we have x1 plus 1. This is equal to x2 minus 1. Okay? F of x2 is what? Even function. So we write x2 minus 1. If you put x1 is equal to, it belongs to x1 comma x2 belongs to set of real numbers. See, x1 1 plus 1. 1 is odd. 1 plus 1 is equal to what? 2. x2 is even. 2 minus 1 is equal to what? 1. Is it 2 is equal to 1? It is not possible. So we are not able to consider f of x1 is equal to f of x2. In mathematics, there is a contradiction in it. F of x1 is equal to f of x2 implies x1 is equal to x2. Then we say the function is 1, 1. This can also be defined as f of x1 not equal to f of x2, getting x1 not equal to x2. How can we getting this? See, if I consider f of x1 not equal to f of x2, that is x1. Suppose if I consider x1, f of x1 is equal to f of x2, x1 plus 1 is equal to x2 minus 1. See, x1 minus x2, this is equal to what? x1 minus x2, this is equal to, see, for this x1 plus 1 is equal to x2 minus 1. Then x2 minus x1, if I consider x2 minus x1, 1 plus 1 is what? See, it is possible the difference of even function and even number, odd number is equal to 2. If I consider 2 as a even number, 1 as a odd number, difference of even and odd number should be equal to what? Odd number. We getting what? 2. Therefore, f of x1 is equal to f of x2 implies x1 minus x2 minus x1 is equal to 2, which is contradiction. Because the difference of even and odd number gives what? Even number. This is contradiction. Therefore, x1 should not equal to x2. F of x1 not equal to f of x2 implies x1 is not equal to x2. Therefore, this is what? 1, 1. Okay? F of x1 is equal to f of x2 implies x1 is equal to x2 is also 1, 1. F of x1 not equal to f of x2 implies x1 not equal to f2, that is also 1, 1. In all three cases. Then the next case, if x1 is even, x2 is odd. The same case, right? Similar case. In all three cases, we getting f of x1 is equal to f of x2 implies that x1 is equal to x2. Therefore, the given function is 1, 1. Then what about onto? See, what is codomain? Codomain is set of natural number. What is range? Range is equal to, see, if I put n is equal to x is equal to 1. 1 is what? Odd. Odd is what? 1 plus 1 is what? 2. Okay? Then if I put n is equal to even, that is 2. 2 minus 1 is what? 1. For 3, I getting 4. For 4, I getting 3. This is similar to what? Set of natural numbers. Therefore, codomain is equal to what? Since codomain is equal to set of natural number, this is equal to what? Range. Since domain is equal to code range, therefore this is what? F is on. F is what? 1, 1. Therefore this implies that since F is both 1, 1 and on 2, we conclude F is bijective. F is bijective. Very nice problem, right? But here F is this one is what? F is not 1, 1, but F is on 2. Therefore F is not bijective. F is not bijective. But for that problem, F is bijective. So these are all about types of function. We discussed the definition of function and some functions and important graph, and the main subtopic, that is types of function. There are two types of function, one and on2. If both types hold, then we say the given function is bijective function. If one of those type fails, then we say the given function is not bijective function. And today we did some problems on the expectation. These are all problems will come to your annual examination, so please go through it. In the next class, I will come with the next subtopic, that is invertible function. What is invertible function? F is 1, 1 and on2 implies bijective, that implies injective function. That's all. So that's why I told you these are the problems very important for our next topic, inverse function. Okay? Yes. Thank you everyone. Bye bye. Yeah, this is Abhishek. Thanks for watching my video. Notes for this session is available in the description below. If you like it, click the bell icon and subscribe to my channel. Thank you.